Hello, everybody. I could say good morning, but this would only apply to Middle Europe. And this lecture today will be held by Birte Vestergaard, and I will introduce her to you. And she's a colleague who has been actively supporting and working with us at the International Refresher course for several years now. And she's a teacher of mathematics and geography at the Oslo Steiner School. And for several years, she has developed a concept for self-learning in small groups, and she calls it mathematics as a journey of discovery. And Norway got a new curriculum this year where a lot of emphasis is put on the exploratory element in all subjects. And because of her work, Birte was awarded in 2015 already. And the number of articles and seminars on the subject, and therefore she was invited in 2018 to be a co-author for the most widely used mathematics textbook for upper secondary school in Norway. And from the autumn of 21, a change in the entire mathematics teaching of her school, according to the model of mathematics as a journey of discovery, will happen. So I'm really looking forward to listen to this lecture, and welcome, Birte.
Thank you so much, Robert, and thank you so much everyone for being here. Good morning, good evening, all over the world. It's really a pleasure for me to be here and a great honor. So I will now just jump into this technical things, and I will start to share my screen with you. So in this presentation, I will have two parts. First, I will show you how I teach math as a journey of exploration in general. And then I will invite you to such a journey in the 11th grade when we explore infinity. So this is maybe what many of us think about when we think about teaching math. It is the traditional way of doing it, a teacher standing in front of the blackboard, and so it has been done for over a century. We are so used to this, and also new teachers coming in are really used to this. So this is a way of teaching that is very orientated on the teacher. The teacher is speaking, and the students have to be quiet and listen to what the teacher says. And knowledge is looked at as a kind of thing that is transmitted from the teacher to the students. And they have to remember and be able to recreate what the teacher has told them. They rarely get the opportunity to formulate thoughts themselves. And all students receive the same impact from the teacher. All those errors are the same. And the teacher actually knows very little about what the students actually are receiving or what is going on in the head of them. And therefore, many students, when they lose connection, they just drift away and hide themselves away in the classroom. And this is actually the reason why also a lot of math anxiety occurs. And I will just let two students explain to you what math anxiety is about.
Well, I didn't have a very nice experience with math in my last school because I wasn't that good in math, and every time I asked for help, the teacher always explained the math problem the same way that she did on the blackboard. And there were sometimes I did not understand what she have been doing on the blackboard, and she kept it going on and explained over and over again, but in the same way. And that were really problematic for me because I didn't understand it. And sometimes then I just said I understood it so that she could move on and help others. And that made me get a bad experience with math because I didn't understand it, and then it got boring. So yeah.
That my previous math teacher, she was really unmotivating. She was really unmotivating, and you didn't want to raise your hands to ask questions if there was something you didn't understand, and that made that you didn't understand everything?
The only two words I associated with math was horrible and humiliating. I remember at my previous school, my teacher used to pick out students randomly to answer some math questions, and he picked me out many times, and I was so scared, and I remember I could just focus on like, don't pick me, don't pick me. That was the only thing I was thinking about. And I remember I was so frightened to make eye contact. So I remember I just looked down all the time. I couldn't pay attention.
It was like that, you felt that she was going to be angry, like a little bit angry if you didn't understand. And she will say that you didn't follow in class and didn't listen to what she said. And yeah, so that's why I didn't want to raise my hand.
And those times he picked me, I had to tell the whole class that I don't know the answer, and I just remember it being really, really humiliating. And I remember him always being like, continuing on, like wanting me to answer, and he just continued on like, come on, you know this. And I was like, no, I don't know. And I had to tell the whole class several times, I don't know. It was just really, really humiliating and scary. And I remember I just wanted to skip those classes all the time. I really didn't want to be there, and I didn't learn anything at all.
And it really is a pain to my heart that a so beautiful subject as math should cause young people so much pain when it could actually contribute so much to their development. And therefore, I'm so engaged actually in replacing those ways of teaching math, those old traditional ways that are referred to as passive learning in the literature, really to support the urge in the society, the requests that comes up in all parts of society for replacing this actually with active learning. And active learning, is described as that the teacher is not in the center of the learning process, but the student is that. And the students actually create the learning experience themselves, whatever that has to mean, that we must come back to that. And that means, of course, that you cannot really know what will come out of the learning process. They will learn what they should, but they will also learn other things that they found out themselves. And because the learning process is created from the students themselves, they will actually only learn when they are active, of course. And then you need something, when the students should be active, you need something to make them active. And what is requested also in the literature is we want to get them active in problem solving. We want to awake this inner researcher that we all carry inside of us, this curiosity that is really basically related to being human being, this awakening of questions. Why is it like that? I want to find out. It is a little bit like when you see a Sudoku, you just get the urge to find out. I know the solution exists and I just want to find out. And this actually is something that appeals to human being independent of age, which a solved Sudoku does not. So I want actually to try to give you the experience yourself of what it feels like to meet this question, why, and this curiosity. So here you see a strip of paper, and I make a black star on the one side and a red star on the other side. And I give it a twist and put it together. And now I just put my finger on the red star and pull. And here we have the black star. So the black star and the red star are now on the same side of the strip. The strip has only one side. It is called Möbius strip. So now we take our Möbius strip and we want to divide it into 2 Möbius strips. But we didn't get that. We get another strip with a double twist. Now let's put the finger at the black star and pull and see, wow, we did come to the black star again. So now the black star and the red star are of each side of the strip. This strip has 2 sides. We continue our exploration, make a new Möbius strip, and now we want to divide it into 3. We want to have 3 Möbius strips. And what do we get? 1 Möbius strip with 1 side and 1 strip with 2 sides. So maybe you can just feel this urge, this curiosity coming up. What would be if we divide it into 4 or into 5? Would there be any rules that we could discover about what kind of strips would come out of that? And that is exactly those questions, those why questions that we want to awake, that can be the driving force for exploratory processes. So we want to let the student meet those question whys, but it is as important as they meet the question whys that they will also come to some aha experiences. And that is important for many reasons. First of all, when you get this aha experience, you will just, wow, I did find out. It is, you know, this dopamine kick in your brain that just wants to let you experience that once again, actually. So you are encouraged to go into the next why question. But also when you get aha experience, it will actually raise new questions that you also would like to investigate. And so it just continues. And when you get into this circuit of why that meets the student and aha, then this can be a very driving force actually in this active learning process when you establish this kind of culture in the classroom. So now the question is, how can you do that in practice? And something that I have learned here in Kassel, very much from my good colleague Rolf Rospigalli, is to make classroom dialogues. It is a really beautiful thing where the teacher creates this situation of why arising in the classroom. The students get curious, and the teacher also encourages the students to think themselves and come up with the ideas and collect those ideas at the blackboard. And some of the students will participate in this development. They will be very active and contribute in the development of mathematical thoughts. And the mathematical rules are developed in this conversation in the classroom. And I really appreciate this way of doing it very much. I also do it myself. It has the advantages that you can really go into what the students are saying. You can really meet them in what they are saying and take that up and just continue from this point. So it is a very creative process that really occurs in the moment. But it also has the disadvantage that many students actually do not participate. You don't get everybody active in this discovery process. And the students that do get active maybe can contribute once or twice in this in such a lesson. So I have asked myself, this circuit of active learning, can we find a way to amplify it so that this activity will be even stronger? And for that, I have developed a way where the why is not met by the student alone in a big class, but is met for the student in such a team, in a team of 3 students. I like to have 3 students because with 3 students, you have a diversity of ideas and skills. 4 can be too much. You can also have 4, but 4 students in a group has the tendency to split up in 2 plus 2 groups. So I like very much to let the students meet this question why in such a group, and that the aha experiences come out of this. But for doing that, you need materials that will make the students meet those that will arise the question why for the students, because now you don't have the teacher in front who is leading this dialogue in the classroom. And for this, I have developed what I call discovery sheets, and that are those that are published now in Norway, some of them. Here you see a group actually with 4 students working with a discovery sheet. And as you see, they are prepared in the way so that the students can just go right into it. They don't have to copy anything from the blackboard. They can just go right into the mathematical process. It is like a set table that actually also really invites the student to do it. I will just show you some examples. Here you also see the table they can just go right into. And the mathematicians among you will see that here are discovery sheets for many different levels of math. So I have made for the whole upper school, not finished, but done a lot. So I teach math as a journey of exploration where the students discover mathematical laws through active learning with discovery sheets in small groups. And now I just want to show you how it looks like in the classroom here. So we just saw before the traditional way of learning mathematical laws is the teacher explaining at the blackboard. And now you see when you work with discovery sheets in small groups, you get this kind of communication structure in the classroom. Before I go into this, I will just let some students give voice to how they experience this way of learning.
It is something cool about sitting by yourself and solving a task and being like, wow, I understood this, wow, because that gives you confidence in one way, but I have had the most fun with doing math when I have done it with others.
Most people have like at least one strength within the maths. They're thorough or they're creative. And when we work in groups, I really think you can kind of mix them together and you get a way larger kind of knowledge. Some
tasks I started and I had really no idea how to figure it out. It felt almost impossible. And then you just have to start somewhere, and you started and it didn't work at all and you had to try something else. But when you're working in a big group, someone will always be, wow, okay, this works. And then you can jump to that and be like, okay, wow, then we work from here. And then other people in the group will say, oh, I made it this way.
Well, that's also one of the things I kind of like with the groups. Sometimes I get put with people that I don't really know. And first off, I'm like, oh, I wish I was with my friends. But then it's actually kind of an okay icebreaker to be in a group together, because then, even though we don't really talk socially, you kind of talk about the assignment, and then you kind of get an impression of the person you're working with or the people. Even though you're not like talking about who they are and what they like to do and stuff, it's still like I kind of feel a bit safer when I've kind of talked to them and gotten a feeling of how they like their atmosphere. And that's actually quite nice, because I feel like it kind of softens that first impression that you just have about some people. And that also, I think, connects the class more.
If a student knows a bit more than the other student, it really doesn't matter, because the point of that student that knows a bit more is to, in a way, try and help the others to understand what we're trying to do, or what they're trying to or what they're missing. And in that way, the student that's trying to help the others learns a lot more, gets like a better understanding of it, and the student that is doesn't understand it a bit, or doesn't understand it, will get help and doesn't need, or regularly doesn't need a teacher.
Everyone has this like, we have this task and we need to solve it, and it's difficult to explain, because it's a special feeling sitting there, and yeah, it's almost like a treasure hunt.
So learning math as a treasure hunt in a way where you really get in interaction with other people, you help each other. It is also a way that really connects the thinking and the hearts, the feelings and the will, you know. And it is also a big advantage from this way to teach that you as a teacher immediately see if a student drops out of the teamwork. You can just go there to the group and you can help this student to reintegrate because they actually want to be a part of this community. So you can do that, take them in again. You will also see that those small groups is a very much more safer place to be for shy students and for weaker students. You can see shy students who would never speak out in class suddenly really blossom as they contribute in the work in such a teamwork. And after this, they will also be more likely to contribute in the class situation. And you can see very, very beautiful situations with weaker students when they dare to ask questions, when they dare to open up and say, well, I didn't get it. That appeals very much to stronger students to explain. And sometimes you see half-an-hour sessions where stronger students explain to weaker students, which you could never have in those blackboard situations. Then, of course, you can say, is that beneficial for the stronger students? Shouldn't they just continue their mathematical journey and develop to the maximum of their potential? And I will just let the students themselves say something about that.
I feel like I learn a lot of teaching others because then I say the words out loud and not only in my head.
Of course, it's helping me understand the subject even better, and it's a good feeling watching other people also understand it.
And I love to explain to others. I love to try to explain as good as my teacher does.
When you get the experience that math is not just for you and not just valuable for you, but when you can use mathematics to lift people up around you, and it makes mathematics a lot more important.
Wow, listen to this one. When you can lift people up around you with math, it makes math a lot more important. And you must know this is a star student, you know. So yes, it is beneficial for stronger students to explain to others. You have really to understand the subject very, very well to be able to let others understand. That is also why we understand things as well as teachers. We have explained this 1,000 times, you know. So this is actually a way to have differentiated teaching in the classroom, because the stronger students are challenged when they explain to the weaker students, and the weaker students will learn the subject. So you have differentiated teaching in a very economic way. You will not have to split the class up according to levels, and you will not have to have different tasks for everybody according to level, because you use the differences of academic level as a resource in the classroom, not an obstacle. And this is a very smart principle, actually, that we know from nature. And when we talk about this in nature, we talk about symbiosis. And therefore, I call this kind of teaching where you use the differences in academic level as a resource. That kind of teaching I call symbiotic teaching, and it is an extremely economic way to teach, actually. So now let's just get into a little bit more about this structure, how it works. As we have said, it is differentiated and symbiotic teaching, and every student really becomes active participating, and no one will really fall out, because you see it immediately. Of course, it happens that somebody falls out, but then you just go and reintegrate. So in the end, nobody will fall out. Because they cannot hide, you know, they cannot hide like in the classroom. And the teacher now has a completely other job as before. The teacher, I'm often just in the middle of the classroom, and I really have an ear in every group. I know what is going on. I know, well, in this group here, they are struggling, but it is still productive struggling. I will just let them continue on their own to train this capacity to struggle. this group, they have gone over a limit where they are just about to give up. And then I just go there and say, well, what have you thought? And they tell me what they have thought. And I say, well, what if you write that there? And then suddenly they see new things just because of my, little hints to look at their results in another way. And everybody learns to cooperate with everybody because the groups are randomly set every day. And that also contributes very much to the feeling of we are a society in the classroom, we are a community, and the students really love this feeling. They learn, of course, to communicate their mathematical thoughts to others, and they learn to understand mathematical thoughts of others. And then the mathematical rules are the result of the discovery process, the students themselves. That it is the same as you have in those discussions in the classroom that I told you before. But now it comes up in the small groups. And I have actually catched such a moment. I just will show you. So I'm standing and filming directly in the faces of them. They don't even see that. So now this group has discovered a new rule of stochastic, and of course they just want to share this with the whole world. This group, they say this is this group, they have discovered this new law in stochastic, and the others have not. And of course, as a teacher, you must see how to integrate this discovery in the whole class so that everybody will carry this discovery further. So how can you do this? How can you do this? You ask this group to make a blackboard presentation, and this presentation should be so good that everybody understands. And I will just, it looks like this, they have really prepared. It is another rule they have discovered. And this is a challenge. I promise you, this is a challenge also for very skilled students. I will just give you a taste of what it's like, what the atmosphere is like. Don't care about the mathematical content. Just look on the communication and be aware of the atmosphere.
Ja, vi skal da finne arealet som mellom den blå og den røde grafen. Okay. Så altså fra -1 der, hele det arealet der. Skjønner dere hva jeg tegner da? Ja. Men også da under her, fra mellom f og x og x-aksen. Skjønner dere da at det det arealet vi finner hvis vi tar integralen av f og x? Ja.
So for the mathematicians at Bonn, I will just make a short comment. Of course, we know this is just the difference between those functions, but they don't know, the students. And they actually found this area, but in a very complicated way. And they presented how they have done it. And then we can discuss further. Maybe we could do that easier. And then we find out how to do it very easily afterwards. So we do have blackboard presentations also in this way of teaching, but now it is students standing at the blackboard. And before I say something about that, I can let the students tell what do they care about standing at the blackboard and explaining what they have found out.
You have to make sure that everybody understands what you're saying.
So I try to think, okay, how can I best suit it? How can I simplify it and make it so easy to understand that everybody gets it, like the first try? That is my goal, in a way.
If 5 persons don't understand what you're saying, that's not good enough.
So I can maybe use like different color with different color chalk, try to actually show the steps in between. And then at the end we have a questions round where we get questions from other students. And in those question rounds, students can in a way try and explain what they don't understand or point out stuff that I might have missed in my presentation.
I sort of explain things to myself as well as explaining things to others.
Even if I didn't make the greatest presentation ever, which is my dream, and I hope I'll get there someday, it's all fine because everything that might have been unclear will be uncovered after we take the questions round and we get those questions answered. And so I learn a lot more from that.
I try to explain it in a different way so that he or she could understand it.
Going from one step to another step might have been a bit unclear. That might be covered up, and then I'm like, oh right, next time I'll do it like this.
Yeah, so they are really concerned about doing this so clear that everybody gets what they have found out. And all the students sitting here, they are already engaged in the subject because they have worked with the same discovery sheet, so they are really curious about what did they do. They are kind of prepared for this presentation in another way as you have when the teacher is standing and doing presentations. What is the job of the teacher then? The teacher has to make sure that this will be a success for the student standing here. No matter of that this is skilled student or not skilled student, this must be a success. And when I have students that are not that skilled, I really train with them before they go to the blackboard so that I will be completely sure they will just nail it, you know, and they just grow 10 centimeters when they have done such a presentations. They are so anxious before entering the blackboard, but afterwards it is just a big reward for them. And it is really a point of growth. When strong students are standing there, you know, they can be really challenged from the questions from the classroom. And the teacher has the job just to make sure that every questions are asked. And the teacher say, well, now you must just explain this again. It was not clear enough. Try again. And they try again. And they then ask, did you understand it now? No, it was still. And then you have a really beautiful situation coming up where strong students really are doing a lot of effort to explain so well that the weaker students understand. They are actually challenged from the weaker students. And that is just so beautiful. Now you can ask, well, me as a teacher, you know, I have 20 years experience standing in front of a class. I can do really good explanations. How can I ever be replaced from a group of students? Will that be as good as when I'm doing it?
My teacher gives way better presentations.
Well, the presentation might be cleaner from the teacher. But I feel like from the student, it's much more relatable in a way. I understand where the person is coming from.
When a student does it, I think it's really good learning experience for the student itself and also for the people around because it kind of forces them to ask the right questions and that also forces the presenter to answer them.
I feel like I understand it better actually when a student does it because it comes from a place of equalness and understanding. So yeah, it is it's actually a bit better. No offense.
No offense. It's actually a bit better because it comes from a place of equalness. It counts. Okay. But it is also, well, if we just go one back, I think we all know what it is like the first time standing in front of the class. It is a really vulnerable situation, isn't it? And it is also for the students. And you should really be aware of that as a teacher, that this must be totally safe for them. And you are there not to challenge them, those at the blackboard, but really, really to support them, to be a guide for them. And they must trust you. Listen to how sensitive this actually is.
My earlier experiences of going to the blackboard isn't that good because earlier classmates have made fun of me. But so it was a bit of a challenge to go to stand up and walk through the classroom to get in front of the class.
Oh, I found that super scary to begin with. I think the entire first year I might have done it once, but I was I was completely panicked and my brain just shut down.
When I first stood there, it was so much easier to focus on what I needed to do, because of my teacher stood there and helped me. And if I did something wrong or said something that I didn't, that wasn't right, she helped me with a little word here or a little sentence to help me.
It was also just seeing other people do it, and even seeing some people fail, and me having failed a lot myself. After a while, it kind of softens a bit up the stress and the pressure of it.
Even if I'm doing something wrong, they help me out and help me think in another way that may help me solve the problem.
Yeah, so you may have students, suddenly they don't know anymore, and then you say, oh, that's no problem. We have a whole group here of colleagues who are just here to help you. Come, what do you think? Come support. And then you will have a really warm feeling of everybody supporting this group at the blackboards. And therefore you can get a situation where it's actually not scary. And this is also a big gift for the students to bring that with them into the world, to could stand up in front of an audience and present what you have thought. But the classroom must be a safe room, else this cannot work. And what do I mean with a safe room? This is really where the rubber hits the road. It must be safe to ask, safe to fail, and safe to bring in your ideas. And really, really safe. As safe as it is for this little bird to be in this crocodile mouth. Because it is safe for the little bird, it can go here and pick food from those big, dangerous teeth. And the crocodile gets clean teeth, something which would be very difficult to get with his crocodile feet, you know. So they can benefit from differences. They can benefit from differences only because it's safe. And when I talk about this symbiotic teaching, you know, this is a symbiosis from nature, benefiting from differences. In the classroom, this teaching, this symbiotic teaching can only happen when it's safe. So how can you get it safe? Well, there are many things, but one thing that is really important and that I always emphasize as the very first thing when I enter a new class is that our working together must be based on actually a contract of mutual trust and responsibility. And it is very easy to say, but not that easy to live. Both the teacher and the students have responsibilities, and it is the responsibility of the teacher that now I just say all explanations, but I don't mean explanations like everything is just transmitted from the teacher to the student, but all processes, all steps of thoughts that are taken in the classroom must be so clear that everybody understands. And that is independent if the steps are taken from the teacher or from other students. Everybody must be able to follow the steps. And this is difficult. You know, it's so easy to teach math in a way that nobody understands. It's super easy. And therefore, the teacher and the presenters at the blackboard also need support. They actually need that the students listening immediately ask if there's something they don't understand. It looks so easy, doesn't it? But it is so difficult to get the really living reality in the classroom. And therefore, you should just ask the students one question.
What do you need from the class, from the teacher, in order to ask questions in class about things you don't understand?
Well, I need to feel secure about them, and I need them to support me and help me when there's something I don't understand, and not laugh about me and say, oh, you didn't understand that, that's so easy.
I have to feel the safety from my teacher and from the student. The safety of, for example, kindness. That everybody wants everyone to understand the questions.
I need them to listen to me and really listen to what I'm saying and try to understand where the problem is, and then try to help me.
I need like that understanding that you're not stupid if you don't understand it right away. I just need a good environment, really.
I think, first of all, I need the opportunity to do it. I need an environment in the classroom that encourages the students to take the chance and go try it without, being afraid to do anything wrong, but just feel like it's an open space where you can have discussions and how do you say, brainstorming.
If you want to be a good teacher, you have to be you have to care about your students, and you have to make sure that everybody gets what you're talking about. Yeah, I think it's really important that you ask questions. Did you understand it or did you not understand it? Because then, and make trust to the students so they can trust you, and that you can trust them to know that they will ask questions if they don't understand. And also to make it say that it is normal that someone doesn't understand what you're saying, and to make sure that everybody in your class know that it is okay to ask questions, even if it's a really dumb question. Every question is a good question if they don't understand what you're saying or what you're trying to learn them.
Yeah, you can get something out of every question. And even though a question is asked for the third time, you as a teacher don't have to answer it. You can just ask the class, can somebody explain it better than me? And then you have symbiotic teaching and they will not be bored. So what we have heard is that asking questions is something you as a teacher must trust that they do, but they will only do it if they really never, ever get humiliated, not from you as a teacher and not from the classmates. The other thing that is important is that you give exercises and discovery sheets that the students are able to manage. Of course, they should struggle, they should come into productive struggle, but it is very important that they also come to this aha experiences. And if they don't, well, I always take responsibility and say, well, it was too difficult, I'm sorry, I will make it better another time. The students have the responsibility really also to go into it and to exercise, and also to strengthen this ability actually to struggle, even though it's hard, not to drift off in other things. And you can demand that from them. So this is what I mean by this contract. It is really something we agree on, of mutual trust and responsibility in the classroom. And when you make this the living reality, you will experience a warm atmosphere of empathy. And that is what I call emotional attunement. We get attuned to each other just like musical instruments. And that is what I mean with this safe room. Well, now you can ask, do you really have the time? We have a colloquium to go through. Do you have the time for all this questioning and all this emotional attunement stuff? Is that efficient?
I feel like our engagement is like compared to other classes super high.
I don't think I've ever been on the phone in maths. I can't remember seeing anyone do it either. It's like, I think we have a really good environment.
Yesterday we worked without a teacher, like the full entire class, which was like 2 hours or something. And we just went at it, like, okay, I don't know this idea yet, or I can't remember, what were we doing again? The other group, oh, let me help you, bam, 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 bam. In the end, we were like up on the whiteboard or blackboard and like working it out all together, which was really great. It was a nice experience. Yeah.
When you get, this period of focus in which everyone just works and it's sort of like this power field of working with mathematics, that's a good feeling.
I think my learning process has actually grown, like almost exponentially, I think.
Like, you understand the formulas, you don't just remember them, and then you have like you have a more solid foundation for the subject.
If I'd been like tied to a book, I'd be like studying it like a Bible in a way. It would be very like, oh, follow the book, and do a lot like that stuff, which is not really great because it doesn't like get you thinking yourself.
I also think it makes it way more exciting learning when you kind of split, like when you're sitting there and trying to discover it, and suddenly you get like a little, oh, this is a good idea, and then suddenly you just like get really excited and it's nearly difficult to stop.
I'm just deeply involved in what I'm trying to learn, which is great, because then I, in a way, learn better. So I feel like I've just been an overall better student after throwing the book away.
I think this way of learning is efficient.
Yeah, it is efficient because they get so engaged and they actually really work a lot also at home, and they suddenly come and say, look what we have found out. And I say, super, now you can make this Blackboard presentation. I'm looking forward for that. And actually the Blackboard presentations after a while get a kind of reward. They all want to go to the Blackboard and present. And I can say, no, I'm sorry, I have already given this away. So next time. So I have now shown you how I teach math as a journey of exploration, meaning that the students discover the law and the beauty of math themselves by working with discovery sheets in small groups. And that they share their discoveries as gifts to the rest of the class by Blackboard presentations. This is only possible when the classroom is a safe room and it is efficient. So this was the first part. The second part is very short. I will just give you an example because this is about the 11th grade, how this can be done. So how can we awake the question why for the 11th grader? Who do we have in front of us? Well, the 17-year-old student, you know, is more inward directed, is more intellectual and psychological sophisticated, and they really benefit in their development from thinking thoughts that are clean thinking, not dependent on material matters, but clean thinking, you could say. And this you can get when you enter the space of infinity processes. And those infinity processes are also characterized by that paradoxes and contradictions come up. And those paradoxes and contradictions, they are just like sugar for those 17-year-old people. They just eat from your hand when you let them meet that. I will just give you a taste of what I mean with those paradoxes that come up when we enter the space of infinity. So here you have a column of numbers. It is just continuing into infinity. Here we have another column, also continuing into infinity. And you can actually, for one number on the left, find a number on the right. And in this way, you can say you have as many numbers on the left as on the right. But you can also say that the numbers on the right, on the left you have only every second number you have on the right, and therefore you could also argue that you have double as many numbers on the left as on the right. So those two arguments, you cannot say who's right. You have a paradox. So when we work with the students, we want them not only to get into paradoxes, but also to find rules. And therefore, this is not a thing that I would give to the students because they will not find laws and they will not find order in this. So as a teacher, you must think about how can I let them meet this world of paradoxes arising from infinite processes in a way so that they will also could manage it. And for that, I start just with fractions. What will this be? Well, it's easy. We find a common determinator and we can sum those fractions. But what will this fraction be? If we just continue into infinite, it is clear what the next fraction would be that we should put into the sum, but does it make sense? Will it be something and will we be able to calculate this? At least we cannot find a common determinator because there will not be a biggest determinator in the sum. And this is where the discovery sheet starts. This is the discovery sheet I have made for this question. And you see, it starts with, how can this figure be used to calculate this sum? And then they get into action. You know, they go into it and they see, well, every time when you sum a fraction, it is the same as taking this empty space, making it half, and color one of the halves. Here, taking the empty space, doing the half, and coloring one of the halves, and one more time. So, easy. They can see that. But now is the question, what if you continue? What will that become? And most of the groups, you can hear that when you walk around, they will say it will become almost one. And they actually agree quite a lot on that. But now they are going to this step that I want them to take with this discovery sheet, that I want each and every student to take, and that is leaving this thinking of what is possible in our physical world and going into pure thinking. And therefore I go and trigger them a little bit. They need a trigger for that. And I go and say, well, so what does it actually mean every time you sum a fraction? And yeah, it means halving the empty space and coloring one half. And then I say, okay, but if the sum is almost one, it must mean there's still an empty space, isn't it? And then, yes. And then I say, well, then we can just halve it and color one half, and that would be the same as summing one more fraction, wouldn't it? Yes. And then I say, well, discuss that a little bit further. And then I just leave the group and go to the next group. And after a while, every group actually find out it must be one. They take this step of development into thinking infinite processes, leaving the material way of thinking. They take that with each other. And so we are ready for the next challenge at the discovery sheet. And this is calculating this sum. Now they have to find a figure themselves. And I will just show you how one group solved this problem here. So we have a third plus a ninth plus a 27th. So, and then we have exactly the same on the other side. And by doing it this way, there will be this space in the middle that gets smaller and smaller. So, and now this student is actually standing here and arguing why, if you really do continue this sum into infinite, why this space will be filled out and the sum will become a half. Now it really comes from her. She explained this to others. Actually, she is explaining it to parents. It is a parents meeting where we have mathematics concepts. So, and we continue. How can you calculate this sum with this figure? It is quite another figure, isn't it? So then you come into new thinking processes and really have to be creative. And here we shall see what one group did. So we say we have a quarter, that comes here, and a 16th, and a 64th, and so on. And we see this whole square. You can actually see a form that is repeated and repeated in different sizes. And this form is put together from 3 smaller squares. And in the same form, it is the same, you know, and 3 smaller squares. 2 of those are not colored, 1 is colored. 2 are not colored, 1 is colored, and so on. And this process continues into infinity. The whole empty space will fill up again with those forms. And you can see, therefore, only a third is colored and the sum must be a third. So this is our results until now. We go to the discovery sheet and ask, are there any patterns to be discovered? And the students found out, okay, we can write those sums in another way. They have learned it's always good to write things in another way to discover patterns. And all the groups will find out, yeah, of course, we see a pattern. Now we can also easily calculate this sum. It will be like this. Wow, we have found a pattern. And the next step then for them is, can you formulate this pattern that you see as a mathematical rule? Yes, we can. This is a mathematical rule we have found. They have taken the step into thinking infinite processes, and in this, they have met those paradoxes, but they have also found rules concerning this world of infinity that brings the same certainty into infinite processes that we know from our processes until now. So we have had a really strong aha experience out of this why. And of course, the new questions arise, and it is very different what some students come up with for questions. But for instance, this one, will that also become something? And I will not make that with you now. You must find out yourself. I will just give our students, our math anxiety students, the last word.
I started to feel more safe in class, and then I started to ask more questions. And when I started with that and felt more safe, it was funnier to do math because I started to understand it. And when you understand things and feel safe and not that stupid, my experience got very nice, and I felt good about myself in math. And that was a really nice experience for me. And I also think like the whole class feels safe about each other, and that helps a lot in math. And now I really like math. I think it's very exciting.
I have experienced that math has changed. Now I feel that I am able to understand math.
I got a completely different teacher than my previous teacher was.
When there's something I don't understand, I raise my hand immediately and ask my teacher. That is because I know that I will get good enough help. I know that I have the safety from my class students and my teacher to get a good explanation. And yeah.
She's telling her students all the time, several times, even though you don't understand, it's my fault because I haven't explained good enough. And I love that because that makes me feel not stupid. And she always says that you're not stupid if you don't understand. It's just me, I have to explain it in a different way. And I love that she just continues on explaining and explaining until you get it.
Now I feel that I understand things that I want to understand in math. I just have to get good guide and good explanation of the things that I don't understand, and then I feel able to solve any mathematical task or problem.
My self-confidence has changed a lot.
I'm not scared anymore, I'm not nervous, I'm just excited and I'm enjoying it actually. I'm like first time in my life I'm actually enjoying math. I'm enjoying learning new stuff, I'm actually learning new stuff, and it just feels great now.
And the feeling that math gives me when I understand a question or a task that I didn't at the first get, it's very nice to understand it, and I'm getting like very happy with myself.
Yeah, I've gone from hating math to actually liking it a lot, to actually liking to learn new stuff, and it feels so good, that feeling I get during math. So yes, it has changed.
So it has changed, and it feels so good. Well, it also feels good when I eat sugar. But this good feeling that the girl here is referring to, it is the good feeling you get when you do the right development steps that you need. So with this, we have come to the end here from beautiful Norway. Yeah, and the things I will do as the next, I will just mention that, is actually to combine those discovery sheets, to publish them further on, but also combine it with teachers training. Actually, how can you learn to use them so that you can have this safe room in the classroom, so that you can support the groups, and so that you can integrate the Blackboard presentations in your teaching. So before I finish, I will just say you are very welcome to reach out to me if you have any comments or questions or ideas or something that just comes to your mind that you want to share with me. I will put my email in the chat. But before I do that, I will just say thank you so much for joining me. It was a pleasure. And then I will see if I can finish the presentation. Yeah, now we're back. So thank you so much. 5 minutes after time.
Thank you very much. It was really enlightening.
So, Birte, thank you very much for this really interesting talk. And I think if you're going to publish something, I think since most of us are not really fluent in Norwegian or Danish, so it would be helpful if there were some of these sheets or maybe some of this, or maybe you change just your teaching language in your in the Steiner school to English.
Yeah.
This would make it a little easier for us to follow some things.
Yeah, so it is not a problem. It is so that a lot of my discovery sheets are already published in Norway. And this is just for a German or English publisher to take contact with my publisher.